गुड इवनिंग, कैसे हैं आप? आज हम लोग बात करने वाले हैं केमिकल कैनेटिक्स के सेकंड पार्ट के बारे में, विच इज द इंटीग्रेटेड रेट लॉ एंड जीरो ऑर्डर रिएक्शंस. एंड एज ऑलवेज, क्या आप एनसीईआरटी पढ़ के आए हैं? सी, इन द स्टार्टिंग आई एम गोइंग टू क्विकली शो यू व्हाट वी डिड इन द लास्ट सेशन. एनसीईआरटी से, बिकॉज एट द एंड ऑफ द डे जेईई मेन, नीट, word to word things have been coming from NCERT, CUET, जो भी एग्जाम की आप तैयारी कर रहे हैं. सो व्हाट आर वी वेटिंग फॉर? लेट्स गेट स्टार्टेड. प्लीज़ अगली बार NCERT पढ़ के आएगा अगर नहीं पढ़े हैं. इफ़ यू ऑलरेडी बीन रीडिंग NCERT, that's all you need to understand what we're going to be doing in this class. मेरी आवाज़ साफ आ रही है? Are you able to hear me and see me clearly? Please let me know in the chat. ठीक है? And NCERT, let's get started. Hey Bharat, what's happening? Thank you for joining in. All right, मतलब आवाज़ साफ आ रही है. That's good for me. Yeah, this is the PDF that we opened up last time, right? So broadly, हम लोगों ने ये सब चीज़ों के बारे में बात की. Okay, we spoke about what is the average and instantaneous rate, and we also figured out how to express the reaction in terms of the concentration terms. ठीक है, तो रेट कांस्टेंट की हमने बात की, द प्रोपोर्शनैलिटी कांस्टेंट, एंड ऑल्सो द फैक्ट दैट के द इक्विलिब्रियम कांस्टेंट, मैं वहाँ ऊपर पिंक से लिख रहा हूँ. व्हाट हैपेंड हियर? ओह, आई थिंक इट वेंट इनटू सम कूल very big mode. I don't know how to get out of that. Okay, cool. Does some weird stuff. Anyway, K is equal to KF by KB. ये दोनों चीज़ें हैं आपके kinetics की. And this chap right here, this has to do with equilibrium. Hold on, let me reduce the size of this guy. Can I reduce it? Yeah, all right. This is better. Cool. Yeah. So ये हम लोगों ने we did all of that, yeah. And basic idea था कि stoichiometry पे dependent होगा the whole rate का equation, right? 1 by A dA by dt minus of that if it's a product will be equal to 1 by B dB by dt if that is a product. Reactant में negative हो जाएगा. We saw these beautiful graphs, yeah, instantaneous rate and average rate के बारे में. So what are we going to do today? We've done all of this last time. आज क्या करने वाले हैं? आज we're going to focus on what is order. Okay, ये x और y हम लोगों ने define किया था. What is order of a reaction? And we'll figure out how practically to figure out अच्छा इस reaction का order क्या है. And we'll explore zero order reactions in a little bit of detail today. That's the broad plan. We'll also talk about what is half-life. Okay, half-life क्या चीज़ होती है. First order reaction के बारे में हम लोग कल बात करेंगे. Although I may be introduce you to that today depending on how much time we have. ठीक है. So the focus of today is going to be the integrated rate law. Integrated rate law. देखो, dA by dt is a differentiated rate law. उसको integrate करोगे तो कुछ और expression मिलेगा. ये सब बातों में आपको idea दे चुका हूँ last session में. We will talk about it in some more detail. This graph is wonderful and the most useful thing from this session. Okay, chalo, let's get started. All this will make a lot more sense to you as the session goes on. I'm great. How are you doing, Rajanya? Hi, Ashwini. Hi, Bharat. Hello. Today, orders. खाने का order क्या? Swiggy, Zomato से? No. We're no orders here. We're all friends. All right, चलो शुरू करते हैं इसको. Where are we at? Notability भाई साहब थोड़े छोटे हो जाइए please. Oops. Did I close this? No, I did not close it. भाई साहब, hold on. One moment. PowerPoint. Here we are. All right, great. Let's get started. Oh, chat window and OBS. Okay, now we are started. So, शुरू करते हैं आज का सेशन with what is order. This is a very basic idea. मैं आपको बताया था कि ऑर्डर इज समथिंग दैट इज एक्सपेरिमेंटली डिटरमिन्ड. हमने बोला था कि रेट इज डिपेंडेंट ऑन ऑल ऑफ दीज थिंग्स, राइट? ऑर्डर विद रिस्पेक्ट टू डिफरेंट रिएक्टर्स कैन बी डिफरेंट एंड ऑल ऑफ इट इज एक्सपेरिमेंटली डिटरमिन्ड. मैंने आपको बेसिक आइडिया दिया था कि समटाइम्स द स्टोइकियोमेट्रिक कोएफिशिएंट्स देमसेल्व्स डिसाइड द ऑर्डर. अगर वो हो तो उसको हम लोग एक एलिमेंट्री रिएक्शन बोलते हैं. इफ दैट डज नॉट हैपन, इट्स कॉल्ड अ कॉम्प्लेक्स रिएक्शन. इट मे हैपन इन मल्टीपल स्टेप्स. दिस इज द फर्स्ट थिंग आई आल्सो स्पोक अबाउट इन द स्टार्टिंग ऑफ द सेशन, जहां मैं बोला था कि देखो ये तो कंप्लीटली एक्सपेरिमेंटल चीज है, थर्मोडायनेमिक्स अलग है. नाउ वी आर टॉकिंग अबाउट टाइम. ओके, कूल. सो व्हाट इज ऑर्डर? इट्स द पावर टू विच द कॉन्सेंट्रेशन ऑफ अ स्पीशीज इज रेज्ड इन अ रेट लॉ, and that is called as the order with respect to that species. ठीक है, बट एक स्पीशीज का ऑर्डर निकालने क्या फायदा? मुझे तो ओवरऑल ऑर्डर चाहिए. Why do I need overall order? Because that is what will help me make the small reaction जो मैं लैब में कर रहा हूँ to a big scale. Okay, पता चलो कि अच्छा ठीक है, तो इतना करने से इतना यूज करो जाएगा. अच्छा ठीक है. And it may not always be the case कि it's a stoichiometric quotient. Keep that in mind. So sum of all of these powers is the order. You maybe already know this. Hey, good evening, Shifa. How you doing? Yeah, rate order, absolutely. So overall order is just a sum of all of these exponents P and Q and R. अगर एक का जो है P है, दूसरा Q है, दूसरे का R है. And remember, A is not always equal to, this is a computer's term, okay, A need not be equal to, let me write that properly, need not be equal, ये इसको बहुत ज़रूरी है, बार बार मैं लिख रहा हूँ, A need not be equal to P, B need not be equal to Q, R need not be equal to C, etc. Okay, that's the next line right here. So what are the characteristics of the order of the reaction? पहली चीज ये, that is very fascinating, order can be zero, okay, or a whole number, it can be a fraction, it can be negative, order कुछ भी हो सकता है, it can't be irrational number, it has to be a whole number or a fraction, ठीक है, order negative भी हो सकता है. ये 3 points हैं order के बारे में, which is quite interesting. अब but the more you think about this, it becomes very random. What does it mean to talk about a fraction order? इसका physical meaning क्या है? Physical meaning ये है कि अगर एक reaction सिंगल स्टेप में नहीं हो रहा है, 2-3 स्टेप में हो रहा है, देन यू विल स्टार्ट टू सी ऑल ऑफ दीज थिंग्स, दिस एंड ऑल ऑफ दिस. Zero order reactions are very interesting, and there are few, like there are not too many of them in nature, but we'll look at a few examples. Okay, so here is one example. इस केस में देखो stoichiometry के हिसाब से there is a 2 here before N2O5, so maybe you think order इसका 2 होगा, but नहीं, इस भाई साहब का order 1 है because nature decides that. Okay, so overall order is just 1 because there is nothing else over here. Remember, we are talking about just a forward reaction. Okay, मतलब disappearance of N2O5. Another example is this. Look at this, such a scary order, right? Scary thing. You got 5Br minus BrO3 minus 6H plus Br2 and H2O. Now, this is a redox reaction. Is this a redox reaction? Yes, very much so. Do you know the name of this reaction? इस reaction का नाम मालूम है क्या? Hi, hello Jude, how you doing? What is the name of this reaction? Is this a special reaction? देखो यहाँ पे इसका oxidation state is -1. Here it is +5. What is happening here? It's 0. So it is the opposite of proportionation, also known as proportionation. My English spelling is bad. I'm slightly dyslexic. Comproportionation. Okay, great. It's the opposite of disproportionation. Okay, it's comproportionation. You take a higher and a lower. This is the higher oxidation state. This is the lower oxidation state. और बीच वाला oxidation state आ जाता है. This is a redox reaction. ठीक है, वो सब कहानी बहुत अच्छी बात है, but although there is a number 5 here and number 6 वहाँ पे on the edge, that's all right. The rate law is still just, you know, all of these, which is a very high order. This is a unique case. मतलब बहुत कम बार आपको ऐसे दिखता है कि ऑर्डर इतना हाई है. इसका ऑर्डर कितना हो गया? With respect to all of these, you got 1 plus 1 plus 2, which is simply 4. Very simple stuff. So okay, let's take a quick question. Disproportionation, Snigdha, Ashwani, is you get one that becomes one higher and one lower. This is the opposite of disproportionation. Okay, check this out. Very easy question. 2O3 giving 3O2. The experimental rate law for this reaction is something. What is the order with respect to O3 and O2 and overall? I mean, this is like a 10-second question. There's not even a question that could come in NEET or in JEE, but who knows? आ सकता है, आ चुका है पहले. In fact, this is a PYQ. If you want to look for it, आप मुझे बताओ किस साल का है, कहाँ से आया है. Wait, this one or I think the next one is a PYQ. Anyway, please tell me what you think about this. ओजोन के बारे में मैंने JEE एडवांस के सेशन में बहुत डिटेल में बात की थी. ओजोन ये करता है, ओजोन वो करता है. दिस रिएक्शन इज it's exergonic, delta G is negative, ozone has a blue color liquid. बहुत हमने फंकी बातें की थी इसके बारे में, but anyway that happened some time back. But what do you think this is? Yeah, this is simple. 2 -1 and 2 - 1 equal to 1. So 2 -1 1. Yeah, absolutely straightforward. इसमें ज़्यादा दिमाग लगाने की जरूरत नहीं है. D is the answer. Thank you for that. Next one. Oh, no more questions. Hold on. So again, summarizing, a balanced equation does not necessarily give us a true picture of how the reaction takes place. ठीक है? How a reaction is taking place, you need to figure it out experimentally. Okay? And बहुत कम नेचर में ऐसा होता है कि एक स्टेप में हो जाए. अगर एक स्टेप में हो रहा है, in that case order equal to molecularity. What is this molecularity? Molecularity is literally the sum of the molecules. है ना? Molecularity is in an elementary reaction you sum up the stoichiometric coefficients and that will give you the order. Simple सा है. This is in NCERT as well. Maybe you saw the word while I was talking about it. Okay. So elementary reaction में जिसमें सिर्फ एक स्टेप होता है, उसमें the sum of stoichiometric coefficient is the order of the reaction. ठीक है? Which is also known as the molecularity of that reaction. So in this one of the exceptional cases, ये एक elementary reaction है, single step है, H2 plus I2 giving you 2HI. In this case, overall order is simply 1 plus 1, which is equal to 2. Okay? If you have any doubts, feel free to stop me. I'm not in any hurry, but because I'm telling you बहुत basic चीजें, इसलिए I'm just going with my flow. Yeah. When I have questions, I'll include you guys. All right, Varad, Mehak, good evening. Rajanya, thank you for your inputs. Absolutely, Ashwini. Yeah. All right, great. आगे बढ़ा जाए. ठीक है. For a complex reaction, एक से ज़्यादा step होता है. And here's the catch. The slowest step is the rate limiting step. Rate limiting step. इसका क्या मतलब हुआ? इसका मतलब हुआ जो सबसे धीरे स्टेप होगा वही तो डिसाइड करेगा कि रेट क्या होगा और ऑर्डर क्या होगा रिएक्शन का. ठीक है. एंड अनदर थिंग इज कि ये जो छोटा स्टेप है, आई मीन नॉट छोटा बट जो सबसे धीरे वाला स्टेप है, द स्लोएस्ट स्टेप, it may not have the original reactant or the final product. It may have some intermediates. अब उस intermediates का we'll have to get rid of it. तो we'll do. इस टाइप के सवाल हम लोग बाद में करेंगे. Towards the end of this chapter, we will do 1 or 2 questions like this. ठीक है, जहाँ पे ये हो रहा है, वो हो रहा है. Maybe 1 question. We'll do 1 sort of a theory. एक चीज़ आपको मैं दिखाऊंगा वो करके. In that case, order is experimentally determined. Here is such an example. ठीक है, 3 steps हो रहे हैं. Okay, out of these 3 steps, it looks like the overall order is NO whole square into H2. NO whole square into H2. अच्छा, not NO square into H2 square. क्यों? Because it is possible that some other step, maybe this is the slowest step, maybe. Yeah, I'm just saying a maybe over here. अच्छा, you have seen this by the way. आपने इसको देखा है कहीं पे? कहाँ पे देखा है आपने? You remember SN1 and SN2 reactions? इसका order था 2. इसका order था 1. Yeah, you remember this? तभी तो 1 और 2 है. Okay. Number of steps, this was a 2-step reaction. This was a 1-step reaction. है ना? Pentavalent state बनता है इसमें, right? But we won't talk about this, that's not important. ये वाला ज़रूरी नहीं है, ये वाला ज़रूरी है. 2-step reaction. First step is carbocation formation. Okay. And that is the RDS, rate determining step. बहुत आराम से होता है. Thermodynamically, yeah, you remember ये सब याद है? Yes, like a relay race, the chance of victory depends on the slowest step. Relay race से ज़्यादा, Rajanya. All right, pro. Thank you for joining in. That's lovely. That's amazing to hear your score and thank you for the feedback, pro. I hope you're doing well. आगे क्या plan बन रहा है आपका? Ping me on iTeachChem and we'll chat more. Ping, that's me on social media, like not really social media, Telegram, Discord, and all of that. I keep forgetting to put that in here. Hold on. Ta-da-da-da. Thank you for that. Thank you for reminding me. Always कोई ना कोई मुझे याद दिला देता है in one way or another. So this is where I put all my content. It's all on Aakash BYJU'S itself, nowhere else, right? Aakash JEE, Aakash NEET, whatever I've done here, that's what I'm sharing. But I've just put it in one place for you to find. Thanks for the feedback, bro. All right. So Rajana, thanks for that input. Relay race. I'd like to give you another one. Okay. This is a better, or not a better, but this is a more appropriate one. So if you say I've got sand, okay. And sand is going down this sort of a thing. पानी ले लो, sand क्यों? ज़बरदस्ती sand लेते हैं, ठीक है? And you know, these guys, the first step has a slight of a thick constriction. Constriction मतलब कि जो उसका bore है बड़ा है, ठीक है? It's a wide this thing. So now this is kind of thin. मेरे सर के just ऊपर है. Maybe the next step is wider. So in all of these cases, because ये छोटा है, this right here, the middle one, this is going to be the slowest and this decides the rate. It doesn't matter if this can let a lot of water or sand form, okay? But ये बीच वाला, this is the one that's going to be a problem because this can maybe force a lot of water through because बहुत खुला हुआ है. But since ये पतला है, this is the rate determining step, okay? That is a easier thing to understand in terms of rate determining step and all of that. So how do you figure out the rate of a reaction? मैंने आपको बताया theoretically rate क्या होता है? Rate is K, A power some P, B power some Q, C power some R, where all of these are concentration terms and this is the forward rate reaction. ठीक है, okay. There are 2-3 of them. We will look at 2 of them today. ठीक है. Initial rate method and integrated rate law method. Rate क्या था? In fact, all this time, in a very veiled, छुपा हुआ way, we have been talking about this because when I talk about rate, it is something like this, no? dA by dt is something like k something something something, ठीक है? But the graphs, जो मैंने सारे आपको graphs दिखाए, there I was plotting concentration versus time, right? From this, I don't get that. इसका slope, in fact, if the slope of this graph is going to be this, the rate itself. You see where I'm going with this? If you like maths, if you like differentiation, if you like calculus integration, you will love this. क्योंकि जो मेरे सर के ऊपर लिखा है, this term right here, that is a differential rate law. उसको इंटीग्रेट करने पे आई विल गेट अ स्लोप लाइक दिस, ठीक है, नॉट माइनस डी ए बाई डी टी, विल बिकम माइनस डी सी बाई डी टी, डजंट मैटर, ठीक है, बट यू विल गेट अ ग्राफ लाइक दिस. सो दैट इज अ डिफरेंशियल लॉ, उसको इंटीग्रेट करोगे यू विल गेट दिस. So in a veiled and a hidden way, we've been talking about this. We'll talk about that in maybe 5-10 minutes time. पहले let's get over this concept of what is this initial rate method. मैंने आपको बताया था कि क्यों हम लोग concentration measure करना चाहते हैं, because that's easier to do. Rate कैसे measure करोगे? Measuring rate is a really hard thing to do. Okay, maybe at the starting of a reaction, somehow I can measure the rate. Theoretically, let's assume we can measure. Okay, that's exactly what we're going to do. As the reaction starts, we measure the rate. It's a hypothetical idea. If you want to read up more about it, you can on Wikipedia. We're not going to get into details of how you measure the initial rate. It's a very interesting thing. The idea is simple. मैंने concentration कुछ डाला और फिर उसके तुरंत बाद मैंने उसका जो concentration measure किया. But it's a little bit more complicated than that. Okay. Maybe instead of concentration, you'll measure currents, conductivity. Maybe you'll measure pH. You may measure other things, but in a way to get concentration or pressure of the gas. ठीक है. Okay. So what you will do is initially मैंने कुछ रेट मुझे मिल गया इसका, ठीक है. एट द स्टार्टिंग ऑफ द दिस इज वेयर इट गेट्स अ लिटिल कॉम्प्लिकेटेड. या द थिनेस विल डिसाइड एग्जैक्टली. राजन, थैंक यू, दैट्स द इंटीग्रेटेड रेट फॉर्म ऑफ द जीरो लॉ. या एब्सोल्युटली राजन. या सो इंस्टेंटेनियस रेट एट द स्टार्टिंग ऑफ अ रिएक्शन t इक्वल टू जीरो क्या होगा, ठीक है. एंड इट लुक्स लाइक वियर्ड ग्राफ लाइक दिस. दिस लुक्स वेरी सिमिलर टू द ग्राफ जो हमने ड्रॉ किया था, ठीक है. सो इफ आई कीप एवरीथिंग कॉन्स्टेंट, maybe there are three things A, B and C. मैं इन दोनों को constant रखता हूँ and I only change this. I do 1, I do 2, I do 3, 4, 5. I do as many iterations as I like. जितनी बार करना चाहूँ मैं करूँगा. और इसकी वजह से what is the effect on a rate? Okay, that I measure. I change concentration, I measure this, and why am I doing this? With that, I will get the value of this exponent. Think about it from the maths point of view. अगर ये सब constant है, okay, all I'm doing is I'm changing this. This is constant. So what happens? This changes. So one equation, one variable. एक चीज बदल रही है. That I can measure. A I know because I have changed it. So I will get the value of P. And in that way, I have determined the order of A, which is that exponent P. ठीक है? So concentration of A is changed, B and C is the same. That's all we've got to do. So you take three different concentrations. A, like two right now यहाँ पे दो दिए हुए हैं, ठीक है. तो दो चीजें देते हैं. And if we divide both of these rates, then we say अच्छा, then you get an awesome equation, an expression. अगर ये थोड़ा सर के ऊपर जा रहा है, don't worry. We will do a quick question and this will be clear. Okay, all this is trying to say is that this is some new constant. Okay, your original constant was maybe K, and ये कोई और constant है जिसमें हम लोगों ने B par Q, C par R उसको constant रखा है. We haven't changed that. We are varying just the concentration of A. ठीक है. This is the process to solve a question like this. Have you solved a question like this in the past? I feel that the people watching this video may have solved this question in the past. But in case maybe you have never done this in your life, we'll do a quick tutorial. Yeah. Here's a question. Wake up, please. For the non-stoichiometric reaction 2A plus B gives C plus D, the following kinetic data was obtained. Kinetic data मतलब कि वही है. मैं initial concentration ये रख रहा हूँ और इनिशियल कॉन्सेंट्रेशन वो रख रहा हूँ ए और बी की, और उसकी वजह से रेट ये हो रहा है. अब सबकी यूनिट्स देखिए. रेट की यूनिट इज ऑलवेज गोइंग टू बी दिस. के की यूनिट कुड चेंज, बट द रेट यूनिट इज ऑलवेज द सेम. ओके, व्हाट इज रेट? इट इज मोलारिटी, मोल पर लीटर, मोलारिटी डिवाइडेड बाय टाइम, सेकेंड, आवर्स और मिनट्स. ओके, यू गॉट सम एक्सप्रेशन. दिस इज द डेटा इन 3 डिफरेंट एक्सपेरिमेंट्स. ठीक है, कुछ दिया हुआ है. What we want to do is we want to identify the order with respect to A, B and overall order. ये हम लोग को करना है. That is what this question wants us to do. Can you help me with that? Okay. So Ashwini thinks it is A, B par 0, which means A का order is 1, B का order is 0 and total order is 1. Do the rest of you who are on this chat right now agree with Ashwini, or do you have different ideas? Take a minute. I'll time you guys. Timer 1 minute. It becomes actually 2 because मैं थोड़ा आपको explain कर रहा था all that. So I think you have enough time to do this. So all right, Teethraj, easy question. जब आप आए हैं तो बहुत आसान question आपके लिए आ गया. Try it out. Overall order you've got to decide. I told you how to do this, right? Identify कौन सा concentration हम लोग constant रख रहे हैं. Like right here. Here I have kept A constant, okay, and this is 1. And here I have kept B constants. In experiments, I have 3 experiments, 1, 2 and 3. So in experiments 1 and 2, हम लोगों ने A को constant रखा है. In experiments 1 and 3, हम लोगों ने B को constant रखा है. So from 1 and 2, I will get the power of B, okay? The power मतलब order of B. And from 1 and 3, I will get the order of A, क्योंकि A हम लोग बदल रहे हैं. जिसको constant रखना है उसका order नहीं निकाल सकते. Please don't get confused here, ठीक है? The thing that's constant, we can't find the order of that. Then that's time. That's time. Order is 2. Okay, so there are 2 different answers who people here are giving. Let's see. देखते हैं क्या हुआ. तो let's see. Let's find out the order of B. ठीक है? B में क्या हो रहा है? 0.2 divided by 0.1. अरे और order तो इसका बदल ही नहीं रहा. Into 10 power minus 3 by 10 power minus 3. So that's weird, right? So now if you divide this and you see, you get 2 is equal to 1. 2 power x actually. Let's just say power x, where x is the order of B, y is the order of A. So you get 2 power x equal to 1, है ना? Exponents and all of that के साथ. This is basic probability exponents. अब when will something power some x be 1? When x is 0. This is the property of the whole exponents वाला फंडा, right? Exactly. So B का 0 हो गया, ठीक है? Now look at A. A को कैसे निकालेंगे? Now we will divide this by this. So 0.2 by 0.1 equal to 2.4 by 1.2. मैं इसको cancel out कर रहा हूँ. Maybe I'm not writing it explicitly, but that's what's happening. When you divide both of these things, since exponents, the numbers that are same will get cancelled out. Only the numbers that are different, उसको मैं लिख रहा हूँ. ठीक है. So now I have 2 power y is equal to 2, so y must be equal to 1. खत्म, right? So the order of A is 1. Absolutely right, Ashwini. Good job with that. And the order with respect to B is 0. Overall order is simply going to be equal to 1. Right? Exactly. तीर्थराज, स्क्वायर कैसे हो गया दोस्त? Do you want to check your answer? It's okay. Write the steps down. धीरे धीरे करो, कोई जल्दी नहीं है. I told you can do it in a minute, but you don't really have to, right? Maybe in the exam paper you have to, but right now you don't have to do it in a minute. You understand this, तीर्थराज? This is okay? राजन्या, absolutely. के अश्विनी बिल्कुल सही. थोड़ा ध्यान से करके देखो. Yeah, exactly. एक order 1 होगा. Absolutely. Okay, next question. Good, you figured it out. The rate law for the formation of C is what? Looks like we already solved it, huh? This is the answer. dC by dt is going to be equal to Ka. Yeah, that's what your question was. मैं options दिखाना आपको भूल गया पहले. But we've solved it anyway. We made it a theoretical question. ठीक है. All good. Another question. चलो एक और ले लेते हैं. ठीक है. The kinetic study of the reaction 2A plus B giving C plus D, following results were obtained. Similar लग रहा है, but the results are different, and this is definitely a NEET PYQ. You can find it. I think 2013 या 2014 or something like that तब का है. And you will be like, wait a minute, मैं तो JEE की तैयारी कर रहा हूँ. It's okay, कोई फर्क नहीं पड़ता है. आजकल JEE और NEET के questions are very similar. JEE main, NEET, CUET, they're all very similar. Okay. Only if this CUET सिर्फ 12th का आता है. Right now हम लोग, oh this 12th का chapter, हाँ CUET के लिए भी काम करेगा. Comet के जो भी एग्जाम की तैयारी करो, it will help all of you. Can you try this? If you want the option, I can give you the options, but try doing it without the options. Yes, Rajanya, Ashwini, Mehak, Teethraj, Varad. Let's try doing it without the options. आपको ऑप्शन की जरूरत है क्या? इस ऑप्शन की जरूरत नहीं है. Let's ditch the options. बिना ऑप्शंस के आप मुझे बता सकते हो. Let's do it as usual. X and Y. ठीक है? X and Y लेके चलो. दोनों का मतलब tell me X, tell me Y, and tell me X plus Y. Let's do that. है ना? कर लेते हैं. Theoretical सवाल सोच के कर लो. कोई फर्क नहीं पड़ता है. You'll be able to do it. It's not very complicated. थोड़ी सी प्रैक्टिस मैं सोचा आपको इस चीज़ की दे दूंगा. देखो किनेटिक्स में क्वेश्चंस आर वेरी वेरी डूएबल. देयर आर 3 or 4 बेसिक आइडियाज. वन इज दिस. ओके, पहला आइडिया हमने लास्ट क्लास में किया था. दूसरा आइडिया ये है. पहला आइडिया 1/a रेट, दैट इज वेरी इजी. सेकेंड थिंग इज दिस. थर्ड थिंग इज, ठीक है, फर्स्ट ऑर्डर रिएक्शन के बारे में कुछ पूछ लेंगे. लास्ट थिंग इज आर्हीनियस इक्वेशन. दैट्स इट. 3-4 ही टाइप्स के क्वेश्चंस आते हैं इन ऑल पेपर्स. If you focus on the concept, you'll be able to solve them pretty easily. So let's identify the constants here. मुझे experiment 2 और 4 में constant निकल रहा है, which will give me y. Okay. And experiments 1 and 2 and 3, 1 and 4 will give me x, because यहाँ पे 1 and 4 में b constant है. Right? That's what I think. A का 1. Okay. Thank you for that, Ashwini. What about b? A का 1. Okay. I see that happening. Yeah, sure. मुझे भी वैसा दिख रहा है. You think so? What does that mean? Okay, Ashwini, what does that mean? Write it down forms of exponents. Life will be easy. उसको देखो. You're right. Do not do retractive message. बिल्कुल सही. You're in the right direction. So write that in the form of an exponent, and you'll be able to figure it out. Those numbers are very divisible. Very divisible. Yeah. So essentially, if you want the options, ये है आपके options, but options don't matter. We will go over them very quickly. हटा ही देते हैं तुरंत. Options आए, options गए. Okay, this is what you have. So I'm going to highlight. Let's find out B first because ये दोनों हैं. आपने A निकाल दिया तो बहुत अच्छी बात है. B भी निकाल लेते हैं. B भी आप बोल रहे थे ना. So let's divide both of these. We are going to do 3 divided by 2. If you do 3 divided by 2, you get 0.4 by 0.2 power x is equal to 2.88. मैं पूरा अभी लिख रहा हूँ, ठीक है? Divided by 7.2 into 10 power minus 2. Now these exponents are not in the same range, right? Like -1 and -2. I don't like that. Let's bring them both to the same. I don't know what's the mathematical term for it, but let's the same exponent. I don't want that. I want it to be -2. So if I make this to be -2, then I have to shift the decimal 1 to the right. This is very basic, right? This is the idea. Basically, I'm multiplying and dividing by 10. Essentially, मैंने 10 से multiply किया, so 2.8 becomes 28. फिर 10 से divide किया, so 10 power minus 1 becomes 10 power minus 2. Now this looks nice. Right? Now this looks doable. Once, and this goes 4 times. So what you get is 2 power x is equal to 4. So x must be equal to 2. That's it. है ना? A का 1 आ रहा है, B का 4, B का 2 नहीं आ रहा है. देखो ध्यान से. अश्विनी, यू आर ऑन द राइट ट्रैक, बट थोड़ा सा एक्सपोनेंट्स में जल्दी कर दी शायद आपने. तीर्थराज, वरद, महक जी, राजन्या, व्हाट डू यू गाइस थिंक अबाउट दिस? जो मैंने किया 2 power x equal to 4, मतलब बेसिकली I can also write as 2 power x equal to 2 power 2. If that is easier for you to comprehend, then I can say x equal to 2. ठीक है? Or I can also take log. I can take x log 2 equal to 4. और 4 का क्या करें? I will write 4 as 2 log 2. Then log 2 चला जाता है, x becomes 2. जैसा करना चाहो आप लोग कर सकते हो. I just did it quickly over here because I'm just used to it. You can do it in this way. Method 1, method 2. These are the better ways of doing it process wise. ठीक है? 2, not 4. Yeah? Okay, great. बाकी वाला तो is doable. बाकी वाला is doable, right? Let's take this guy and these two guys that are constant. Okay, so now 0.4 by 0.1 power y is going to be equal to 2.4 into 10 power minus 2 divided by 6 into 10 power minus 3. Again, what I'll do is that multiply and divide by 10. When I divide by 10, this becomes minus 3. When I multiply with 10, this becomes 24. ठीक है? So again, I get 24 by 6, which is simply 4. Okay, great. But now don't get tempted and say this is 2. This is 4. इस तरफ भी तो 4 आ गया. So I'm getting 4 power y equal to 4. So y equal to 1. All right. This was a neat PYQ. So 1 plus 2 and the final order is going to be equal to 3. Which is कौन सा वाला था? A का 1, B का 2, right? So D should be the right answer. Although I did not show you the options, I went cheap that way. But it's okay. We figured it out. All right. Good job, everybody. Good job, everybody. Last question on this idea. आखिरी क्वेश्चन, लास्ट क्वेश्चन ऑन दिस आइडिया. सो ओके राजन, थोड़ा प्रैक्टिस की जरूरत है. प्रैक्टिस मतलब धीरे धीरे करने, प्रैक्टिस नहीं. व्हेन पीपल से प्रैक्टिस ना, उनको लगता है कि 10 के बजाय 100 सवाल करो तो हो जाएगा. आई फील कि 5 सवाल करो बट ठीक से करो तो हो जाएगा. प्रैक्टिस का मतलब होता है ध्यान से काम करना. ठीक है? एंड नॉट टू रिपीट. अगर कुछ एरर हो तो उसको रिपीट नहीं करना. यू हैव टू लर्न फ्रॉम योर प्रैक्टिस. दैट इज इंपॉर्टेंट. द रेट लॉ फॉर द रिएक्शन बिलो is given by the expression k into a into b, concentration into b. If the concentration of b is increased from 0.1 to 0.3, keeping the value of a to be 0.1, what is the rate constant? You guys didn't even let me finish the question. Rajanya, Ashwini, and these are absolutely right. It is k. How would the rate constant change? It's constant. It only changes with temperature. Yeah, only changes with temperature. Otherwise, it does not change. Good job. Nobody took the bait there. I'm glad. I'm happy. Nobody took the bait there. चलो एक लास्ट क्वेश्चन इस टाइप का करते हैं. One last question on this. Okay. For a reaction between A and B, the order with respect to A, this is again a PYQ. इस टाइप के सवाल JEE, NEET हर एग्जाम में भर भर के आ चुके हैं. This kind of question. Check this question out. For a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. If the concentrations of both A and B are doubled, द रेट विल इंक्रीज बाय अ फैक्टर ऑफ व्हाट वैल्यू. ठीक है. So you've been given that the order respect to A is something, respect to B is something else. And you're doubling both concentrations. How do you do this? Hey, Hare Krishna Rajput ji. सवाल का जवाब दीजिए. Welcome. So, let me write down what is given to you. If it looks a little scary or weird. क्या दिया है आपको? सवाल में, क्वेश्चन में आपको कुछ इन्फॉर्मेशन दी गई है, right? Rate is KA square times B cube. This is given to you, right? A is 2, B cube. That's it. Okay. Now concentration of both of these are doubled. Double. So let's take it something as, this is rate. Let's take rate dash is equal to क्या? K into A के बजाय क्या लिखें? डबल ना, 2A. पावर क्या होगा? पावर सेम रहेगी. Order not going to change. Okay, great. Let's do that. And then 2B whole cube. To be or not to be? 16? All right. Beautiful. 16 you think? All right. C, तीसरा think 32. All right. So you see where I'm going with this, right? करने का तरीका जरूरी है. What is the process? This is the process. Rate is this, and then मैंने उसको फिर rate dash, some new rate is K. K doesn't change. The concentration is becoming 2A and 2B squared and cubed. So let's take the numbers out. Numbers को हम लोग बाहर निकाल लेते हैं. ठीक है. So you get 2 power 5 times this same expression. So this is rate itself. Okay. So rate dash is basically 2 power 5 times rate. What is 2 power 5? याद है? नहीं याद है. It's okay. कर लेते हैं. 5 बार ये कर ही लेते हैं. 2 into 2 4 into 2 8 into 2 16. अभी कितने हो गए? 1 2 3 4. एक और चाहिए ना? Into 2 32. हो गए 5 गुना नहीं हुआ है. इतनी हिंदी नहीं आती. 2 power 5 हो गया. ठीक है. तो हिंदी है क्या? टेल मी द हिंदी टर्म ऑफ पावर. एनीवन फ्रॉम हिंदी मीडियम हु नोज 2 पावर को कैसे बोलते हैं हिंदी में? खैर 2 power 5 इज 32. ओके. अगर कभी कंफ्यूज होगा तो लिख लो ना. डोंट गेट स्केयर्ड बाय ऑल दिस मैथ्स. बहुत सिंपल है. ठीक है. चलो, दैट वाज द एंड ऑफ द इनिशियल रेट मेथड ऑन हाउ टू कैलकुलेट ऑर्डर्स. ठीक है. व्हाट वाज दैट? क्विक समरी. We figured out, okay, we will take initial concentrations and we'll calculate the rate. And based on that, we will make multiple readings. We will keep one thing constant and figure out the order of individual species that are not constant. So you have multiple experiments and you will divide the two rates and you will divide the two concentrations that have changed, and then you will get the order with respect to that species. And then you'll get the overall order. That was the general idea. ठीक है. That completely, everything I've done, you don't need to do anything more to get all the marks that come from this topic. All right. शक्ति. हाँ भाई अश्विनी जी, 2 की शक्ति 5 नहीं. Pretty sure that's not it. But cool, I'm not going to say that. Let's talk about the integrated rate method, जिसमें बार आपको बोल रहा हूँ पहले क्लास से ही, right? C versus D की the graph of C versus D. The rate law, it talks about the rate of the reaction and the dependency on the concentration itself. But it doesn't tell you about the main thing, which is what you can measure. This is easy to measure, right? Which is why we are going to even talk about this. जब आप किसी लैब में हो, which अगर आप बायोलॉजी लेने वाले हो, if you're going to be a doctor, you're going to have to be in a lot of labs doing experiments, timed experiments. If you're going to be doing chemical engineering or mechanical engineering or biotechnology, you will do a lot of timed experiments. In fact, even discharging of a capacitor, is like this, right? It's an exponential decay. Discharging. This is discharging of a capacitor. If you remember, थोड़ा सा physics मुझे याद है, I think. Okay. And similarly, if you recharge the capacitor, if you charge it, it's called an exponential recovery, right? Recovery. This is charging of the capacitor. तो वहाँ पे भी देखो आ गया ये सब order, time, ये सब यही सब चीज़ें आ जाती हैं. The math you use is different. Maybe थोड़ा सा calculus use कर सकते हो. But idea यही है. ठीक है. Anyway. So we will talk about specifically zero and first order reactions. I think that's all that's in your syllabus from the point of view of this. JEE Advanced में second order reaction भी है, but that's okay. It's not that complicated. I think the good thing about this topic in kinetics is that if you study properly, you can almost certainly get the question from even JEE Advanced if it comes. Kinetics sometimes is not asked in JEE Advanced because it's a thing with जिसमें कम सवाल होते हैं ना. बट नीट में तो हमेशा सवाल आता है किनेटिक्स से, और इनफैक्ट जेईई मेन में भी ज़बरदस्ती सवाल आ रहे थे. हर शिफ्ट में किनेटिक्स के सवाल आ ही रहे थे. एटलीस्ट दिस ईयर इट हैपेंड. वी डोंट नो व्हाट्स गोइंग टू हैपन द नेक्स्ट ईयर. I remember because I just solved the papers on the Aakash channels, right? So we'll talk about zero order reactions. Now these, as I told you, come hai, nature mein, they are kind of low, okay? Generally, for any reaction, yeah, the rate of a reaction is given by this expression, K A power N. We are assuming just एक चीज react कर रही है, right? A is reacting. So K A power N, okay, cool. And general thing is कि अगर N मैंने ले लिया order 0, ठीक है, then the rate will be equal to K. This looks a little funny, does it not? मतलब rate constant है. I mean, the rate of the reaction is constant, and also it happens to be the rate constant. थोड़ी अंग्रेजी अजीब सी लग रही है ना, ठीक है, लिख देते हैं, मैथ्स लिख लेते हैं. The rate of the reaction is equal to the rate constant. Isn't that wonderful? Crazy. It also means that the rate does not change with concentration. The rate also does not change with time. एक ग्राफ मैंने बना दिया rate versus concentration का. I will make another graph, rate versus time. Is this correct? Is this graph correct? Does it seem okay? Rate versus time doesn't change. What do you think? What do you guys think? Is this graph correct or not? From what I've taught you so far, is this right? According to you, according to the people in the chat right now. If you're not watching us live, think about it. I feel this is right. Because the point is that the rate is always a constant value, right? Which means कि it's not going to change with whatever else that changes. Rate नहीं बदल रहा है, unless it's temperature. Temperature के साथ K ही बदल जाएगा, right? You don't think it's correct, Ashwini? What do you think it should be then? आपके हिसाब से थोड़ा सोचो. मेरे हिसाब से same, and I've given you the logic as well as to why it will be constant. The value of rate is K, which is a constant. With time, K does not change. With time, concentration also is not really. With concentration, K is not changing. Concentration जितना भी बदलूं, K की value वही है ना. K is not going to change. Only when I change the temperature will K change. We'll talk about that in the 4th session when we talk about the Arrhenius equation. It's a wonderful thing. It's a wonderful thing. मैंने बोला था अगर आपको ग्राफ्स पसंद है, you love this. If ग्राफ पसंद नहीं है, then you'll start liking graphs at the end of this chapter because I'm teaching it and I like graphs. That's what happens, right? All right. So for a zero order reaction, minus dA by dt will be equal to K A power 0, right? Which then means that minus dA by dt is going to be equal to K. Ashwini, see the math now. See the math, huh? अगर वो लग रहा है वो अजीब है तो maths देख लो भी. It will be easy for you to understand. So this is the differential rate law. Why differential? This is a differential equation. Minus dA by dt is equal to some constant. K ले लो, C ले लो, जो भी ले लो, constant है भाई. ठीक है. Now on integration, what do I get? Integrate करने से पहले सबसे बड़ी बात है, you have to separate the variables, right? So I take minus dA to this side, K dt to the other side. Then we integrate, we put the limits. What are the limits? At time equal to 0 and at time equal to any time t. ठीक है. Similarly, same limits में जो भी time की value है मैं यहाँ पे लिखूंगा. ठीक है. Okay. Now note that there is a negative sign over here. So although यहाँ पे on the right hand side will be time final minus time initial, which is obviously left side में उल्टा हो जाएगा. It will be A initial A naught, which is the initial value minus the final value. So this is getting reversed because there was a negative sign over here. This is by design. There's nothing wrong with this. Think about it like this. This value is always going to be larger than this, right? So it makes sense. Because this is positive. ये भी positive होना चाहिए. So it makes sense mathematically. Ashwini, hold on to your horses. Maths है, सब कुछ सबके पीछे maths है. Half-life, we'll talk about that also. Ashwini has asked a wonderful question. Something called half-life. We'll define half-life and we'll also address Ashwini's question. Okay, ठीक है. So if I were to draw a graph of an equation like this, ठीक है, this is the same as y equal to mx plus c. Y equal to mx plus c. अच्छा. इसमें constant क्या है? This is a naught. This could be my constant. ठीक है? Okay. What is this m? M is my k. Because I'm plotting, what am I plotting? I'm plotting a at time t versus the time itself, right? So यहाँ पे time है, यहाँ पे concentration है. So this is the concentration was, अरे वाह, this is the graph we were talking about all this time. This is the concentration time graph. This is what I was telling you, that this is the practical graph and this is what we can actually plot, and mathematically we have shown you how to arrive at this similar graph. Do you understand how it's y equal to mx plus c? m positive है, no hold on, m positive नहीं, m negative है, m ही तो negative है, यहाँ पे negative sign इधर आ गया, it looks confusing, right? m is equal to minus k, not k, m is minus k, okay? And this constant is this guy right here. All right, wonderful. This is a peculiar reaction, okay? What happens here? इसमें क्या है? A becomes 0, मतलब reaction खत्म, completion. And this is a very unique thing, okay? Reaction gets over at some time and we can find that time. We can find that time at which the reaction gets over. In fact, we'll do that. ठीक है? I can also get the value of k. I can also get the units of k. Units of k are interesting, right? There is this expression. You don't mug this. Please don't mug this. We can figure it out from first principles. What is the unit of k? This is mole. This is second. Sorry, this is mole per liter. This is second or hour or minute. It's basically unit of time. So I can say that this is mole per liter second. This is the unit of k. Cool. Don't mug all of this. Okay. ये ज़रूरी नहीं है. We will get the unit of this. All right. Yes, these are negative slope. This graph came this year. Okay. Yes. Let's go one step back. Ashwini, you are right. Wait, let me think about this. Rate, time, concentration, time. You are right, but let's take it up and let's go one step back. Okay. Let's go distance and time and velocity versus time. Acceleration is the second differential. आप समझ रहे हो? ठीक है? This is just the first differential. एक ही है. You are right. Your analogy works, but just to थोड़ा सा उसको जो refine करने के लिए. Okay. Now Ashwini, you are talking about something called half life. We'll talk about half life. Half life से पहले हम लोग को एक interesting मिलेगा full life. There is nothing called full life. The time of completion of reaction. The time of completion of reaction is when A at t is equal to 0, right? Whatever time that is Tc or the completion time. Okay, that's it. Reactant gets used up completely. In this case, you can see that if I put all of these things, yeah, अगर मैं इसको 0 डालूं, तो time of completion is A naught by K. ठीक है? This is how you get the time of completion. Okay. Now, let's talk about a wonderful thing, which may seem extremely random right now, but this is the most useful thing when you talk about first order reactions, okay, which we'll do in the next session perhaps, most likely. अगर time है थोड़ा बहुत आज भी कर लेंगे. First order reaction is extremely relevant. Half-life helps you understand, and this is very relevant to drug delivery, okay. जो भी आप medicines लेते हैं, they all have a half-life of passing through your body, and that's important. When you're designing any sort of medicine, बहुत अच्छा है, effective है, maybe it's helping you with some vitamin supplements, maybe it's helping you with some dire disease, but उस medicine के components after some point कुछ चीज़ें absorb होती है body में और कुछ चीज़ें have to be excreted out. So that is called the half-life of the medicine. Using the half-life of the medicine, you decide अच्छा इसको दे सकते हैं नहीं दे सकते हैं. तो while making the drug delivery more effective, you have to think about this practical aspect of it as well. If anyone is looking to get into B pharma or those sort of things, कहाँ पे useful होगा मैं आपको सब चीज़ बता रहा हूँ. Half life of any medicine is extremely important. ठीक है? Half life का मतलब क्या होता है पहले ये बता देता हूँ. Maybe you already know this. As the name sounds, when the concentration of reactants becomes half of its initial concentration, it's called the half life. Weird thing. Half life seems weird. Like why half? Why not full life? Or whatever, why not time of completion? Because थोड़ा complicated होता है first order reaction, right? The time of completion is infinite उसके लिए. We'll talk about that. तो इसलिए half life makes a lot more sense. So 5 or 6 half lives में more or less complete हो जाता है. Think about it, right? Exponent से if I have 1 becomes half, then it becomes 1/4, then it becomes 1/8. Every time half हो रहा है ना, 1/16, okay. Then it becomes 1/32. Then it becomes 1/64. At this point, it's almost like खत्म हो गया यार. 1, 2, 3, 4, 5, 6. 6 half life is like non-existent, right? If you take 1/64 कितना होता है? 0.01. मतलब 1% से भी कम बचा है वो. That is मतलब almost खत्म हो गया. 0.01, 64, 1, 4 something ना 401 मतलब 1.41 1.6%, approximately 1.6% बचा होता है, something like that. That's what happens in 6 half lives. Correct? Right? You agree with me there? Generally, अगर हाफ का हाफ हो रहा है तो ये, इसलिए बोल रहा हूं ये हाफ लाइफ इंपॉर्टेंट है. ओके, बट हाफ लाइफ फॉर जीरो ऑर्डर रिएक्शन इज फंकी, इज वेरी इंटरेस्टिंग. 2 हाफ लाइफ में जीरो ऑर्डर खत्म. What? We'll think about this. If you take the concentration value at T half in this equation, ठीक है, इसमें डालो T half. Now we're calculating how to get half life for a zero order reaction. Okay. T half depends on initial concentration. Ashwini, what you were talking about initially in the starting, Ashwini was saying, "Arey, why does T half depend on A naught?" Because we've done the math. You know? Now this A naught changes the second time around. Second time बदल जाता है, right? It is AT at time equal to half of completion time. I'll repeat that one more time. I'll repeat that. Okay. If you were to draw a graph of T half versus A naught, बहुत ग्राफ बना रहे हैं हम लोग. T half versus concentration. Look at this, like भाई ये क्या है? So T half depends on concentration. ठीक है, this graph is okay and weird, but what does it practically mean? मैथ से हमने जबरदस्ती ग्राफ बना लिया. जितने ग्राफ जो मिल रहा है हम लोग ग्राफ बनाते जा रहे हैं, राइट? T half is what? T half is A naught by 2K. We have derived that just now. So we'll plot this versus this. एक और ग्राफ मिल गया. As A naught increases, T half increases. But what does it practically mean for a reaction? For example, of a zero order reaction, decomposition of a gas on metal surface at high concentration follows zero order kinetics. मतलब कि कैटलिस्ट के जो रिएक्शन होते हैं, राइट? मे बी अमोनिया इज वन एग्जाम्पल. आई एम नॉट सेइंग अमोनिया जीरो ऑर्डर है, बट अमोनिया जो है कैटलिस्ट पे रिएक्ट करता है. दैट इज रिएक्शन. डीकम्पोजिशन मतलब जो टूट जाता है, वन गैस ब्रेक्स इनटू टू और मोर गैस, राइट? Example of that is 2HI giving you H2 plus I2, something like that. Here are some examples, right? 2HI giving H2 plus I2. अमोनिया का उल्टा वाला रिएक्शन प्लैटिनम पे हो जाता है. Phosphine H2 plus Cl2, also combination. Okay, cool. What is the meaning of this half life? इसमें yes, तीर्थराज ने बिल्कुल सही बोला. Ashwini, that works only for zero order reaction. We'll see how. ठीक है? Exactly what Ashwini was saying. For a zero order reaction, exactly यही होता है जो अश्विनी ने भी बोला. I don't know if you've seen the chat right now. Ashwini is saying, sir, please tell this. If T half is done, why doesn't the concentration become zero after one more T half? That is right only for a zero order reaction, because खत्म. इसका मतलब क्या हुआ? Why am I saying only for a zero order reaction? If you understand it, great. If you don't, wait for the graph for the first order reaction, you will see why. ठीक है? For now, T half इसका is becomes A by 2, then it becomes okay, cool. If you take the example of this 10 seconds, 5 seconds, 2.5 seconds, in sum में what is happening here? What is the second one? First one तो what you're saying exactly वही है. तीसरा also बिल्कुल सही बोल रहे हैं. Instead of 80, you'll have A naught by 2. Yeah, for a zero order reaction, oops, please आगे बढ़िए. हाँ, equal concentration of reactants get consumed in equal time. This is the meaning of this graph. Do you see that? मतलब अगर 10 सेकेंड में 10 यूनिट हुआ कंज्यूम, दैट मीन्स 5 सेकेंड में 5 यूनिट होगा, 2.5 सेकेंड में 2.5 होगा. यू सी दैट? That is what all of these graphs and everything means. Okay? So if 50% gets consumed in T half, then 50% more will get consumed in another T half. Why? Because of this beautiful graph. This first graph that I showed you. Okay? Because of this. This is T half. So, Ashwini, only for a zero order reaction, what you're saying is true. Because of this statement on top. Is this better? Let's take a question. Maybe this will help. If the reaction 2x giving B is a zero order reaction, If the initial concentration of X is 0.2 molar, the half-life is 6 hours. When the initial concentration is 0.5 molar, the time required to reach its final concentration is what? Please try this. Doable लग रहा है? काफी doable है, right? ये वाला? The first thing is, what do you need? Do you take, and this is an awesome question, do you use equation 1 or do you use equation 2? Equation 1 is differential rate law, equation 2 is integrated rate law. इन दोनों में से कौन सा आप use करोगे? Right? In the question, you have been given concentration and time, which means this and this. So you cannot use this because rate तो दिया ही नहीं है. That's the first thing you have got to realize. भाई आपको कौन सी equation use करनी है? How do I start this question? If I've been given A and T and not the rate, then I don't use the differential form, I use the integrated form. Okay, now that that is out of the way, अब तो बाकी कुछ रखा ही नहीं है. A naught minus AT, I will first get K from this and then I will use that to get this. Okay, do I need to do that? देखते हैं. हाँ, देखो 0.2 is the concentration, ठीक है, and half life is 6, मतलब कि into 1 minus half because आधा हो रहा है concentration, right? Is equal to K into 6. So from that I get K as something 0.1 by 6. I will keep it as this. I will not do anything more. I will keep it as 0.1 by 6 hour. Okay, wonderful. So अब दूसरा वाला भी कर सकते हैं. Let's substitute 0.5 time to reach its concentration 0.2. अब now we don't need this half life and all. Okay, so 0.5 minus 0.2, which is basically A naught minus AT, is equal to K into T. हमको टाइम निकालना है. K I know already, right? K is 1.1 by 6. This also I know. This becomes 0.3. So 0.3 into 6 by 0.1, मतलब 18 हो गया. 18, right? This is going to be 18 hours. I feel this is going to be 18 hours. Cut this out. 3 into 8, 6 is 18. Yeah? All right? You guys think 9 hours? 9 कैसे मिला आप लोगों को? मुझे तो 18 मिला है. Take a minute. Check this out. This should be 18. I mean, I've just proven to you. It's not like I'm जबरदस्ती आपको बोलना भाई होना ही चाहिए. I feel it should be because we've just done it. ठीक है, cool. People in the chat, just give me a heads up and move ahead. I forgot to tell my team, let's make it a low latency mode, not normal latency mode. Let me just leave them a message now so that I forget. I mean, so I don't forget. Where is the group? It's right here. Hi folks, can we make sure that all the videos are on low latency mode and not normal latency mode? I mentioned it before, but just reminding you guys here. All right. देखिए, which part did you not follow, guys? This happened in 2 steps. First thing was कौन सा equation use करना है. I have to use this equation, yeah, because I have been given concentration as time. 2 steps. First step में I will calculate K. Second step is I will use that K to get this here. Yeah, this is the first step. 0.2 into 1 minus half. Why? Because half life दिया है as 6, right? Which means that this is 0.2 minus 0.1. I can also write it like that, but मैंने 0.2 1 minus half लिखा क्योंकि that's easier for me to write. आप जैसा चाहो लिख सकते हो. K into 6 हुआ. So from this I get the value of K, right? यहाँ पे हमने K निकाला है to be 1.1 by 6 hour. Why hour? Hour नहीं है. Hold on. इसका unit is off. My bad. K is not K unit hour नहीं है. It is mole per liter per hour. ठीक है? That's the unit of K. Sorry about that. That's it. That K I substitute back over here. कौन सा expression मैं आपको दिखाया था ना? This is A naught minus AT is equal to KT. A naught is 0.5, AT is 0.2, K मैं आपको बता चुका हूँ. T है यहाँ पे. T we found out. Yeah? We good? Are we all right on this one? सब ठीक है? कोई डाउट है क्या? Are we all right? Ashwini, Teethraj? Ashwini is good. Teethraj, you all right? थोड़ा practice कर लो if this seems a little weird. But that's it. That's all I had planned for you today. Yeah, I'm teaching you very, very targeted stuff because this is what is going to get you through the exam as well. And मैं बार बार यही बोलता हूँ कि practice needs to be done आँख खोल के, आँख बंद करके नहीं, ठीक है? So what did we cover today? We are at that section of our session where we identify NCERT से क्या क्या पढ़ा और what you should be reading for the next class. Oh, this is what you should be reading for the next class. हम लोगों ने अभी यही सब पूरा किया. देखो, we did this graph, we did this whole क्या बोलते हैं इसको, yeah, this derivation so to speak, not really a derivation but बस यही किया. Yes, of course, Ashwini. Yes, absolutely right. Oh, I thought that was, yeah, sure, absolutely. K has to be the same. K is not going to change because temperature is the same. कोई भी reaction, same reaction, कोई भी conditions में अगर temperature same है, तो it's going to be the same. Condition में constant बदल दो, जो भी कर दो, but if temperature is same, it's going to be the same. Yeah? All right. So, yeah, we have covered integrated rate equations and also initial rate method. Where is that? Molecularity order, we have done all of that. Initial, oops, hold on. ये भाई साहब ढूंढ क्यों नहीं रहे हैं? Doesn't want to search? Okay, I've lost search functionality, looks like. Anyway, initial rate method नीचे कहीं पे है. I'm quite confident it's there, right after this first order thingy. Don't worry, we'll do all this next time, ठीक है? This is the agenda for part 3. Please read this. ये सब पढ़ के आइए. Part 3, which is going to be on this Saturday. आज Thursday है ना? Saturday को हम लोग करेंगे ये सब चीज़ें. We will do that. Half life भी मैंने आपको idea already दे दिया है. क्या होता है? We'll talk about half life for the first order reaction. Pseudo first order, we'll also do this. This is also in P3. Okay. Where's initial rate method, man? I feel like I've missed out on this. कहीं ना कहीं यहाँ पे तो था ही. But it's cool. Yeah, we've covered initial rate method and we've covered zero order reactions as well from NCERT. Please read this and share this with your friends if you liked it and subscribe if you loved it. On top are the links to my other sessions. NCERT says, yeah, exactly, Ashwini. I think that's something that we had also mentioned in our sessions. If that got missed, I think almost the same lines are there here as well. But that's okay. I'll explain what that means. Yeah, that's all right. Line लिखिए तो क्या हुआ? Molecularity of rate determinant step is same as overall rate. ये मैंने बोला था, but maybe it got missed. वही था ना कि पानी अगर फ्लो कर रहा है between some sort of constricted flow, तो irrespective of पहला वाला कितना broad है, अगर बीच में कहीं पे बहुत पतली धार है, that is what determines the rate. That's all we're saying. Yeah. That decides the rate. If that slowest step decides the rate, then the order of that slowest step will be the overall order of the reaction. And how do you find out the order of the slowest step? That is an elementary step. Elementary step में molecularity is the same as order. What is molecularity? जो stoichiometric coefficients है ना, उन सबको आप add up कर दो. And almost never is molecularity more than 3. ठीक है? But इसके बावजूद भी ओवरऑल ऑर्डर कुछ 0.5, 2.5 कुछ हो सकता है बिकॉज वो जो सबसे स्लो स्टेप है ना उसमें हमेशा रिएक्टेंट्स और प्रोडक्ट्स डायरेक्टली नहीं होते हैं. समटाइम्स इट कैन हैव इंटरमीडिएट्स एंड दैट इज व्हाट कॉम्प्लिकेट्स थिंग्स. नो, इट इज नॉट थियोरेटिकल अश्विनी, इट इज प्रैक्टिकल. बिकॉज वो स्टेप आया कहां से? हाउ डू यू नो दैट स्टेप इवन एग्जिस्टेड, राइट? सो आई विल टेल यू व्हाट. Have you checked out the questions from NCERT? I feel there is a question at the end. Let me just quickly go through NCERT and tell you अगर वो question यहाँ पे है. Or maybe I've seen it somewhere else where you have to do this. Predict rate. I'll get back to you. I'll get you a question where you have to इसमें इस type का effort लगाना पड़ेगा आपको. ठीक है? Where you have to find out the order of something. I don't think it's in NCERT. It's there in Zoomdal. This is a book that I suggest to people to read. If you are giving IIT, you should really check out Zoomdal, okay? It's a beautiful book. It's for AP chemistry. I don't know if you guys have access to it. This is the book I'm talking about. If you're doing IIT or JEE Advanced, if you're preparing for these exams, this book is a must. You must go through the theory and the content from here. I have solved a lot of questions from this book over the modified version of the questions from here over my sessions. You can check it out. Anyway, I'm done for now. At 8:30 मैं कर रहा हूँ atomic structure का third session, which is going to be on Bohr's model. Come check it out on the JEE channel if you like, and share this video as well with any of your friends preparing for any exam in 11th and 12th standard. Thank you everybody for your time. अरे जिसको presentation के notes चाहिए, you know where that's going to be everywhere. Discord, Telegram, everywhere. ठीक है? Join those channels. The links are there in the description. Please join them and I'll see you there. All right, मिलते हैं फिर. Next session is on Saturday, same time. Bye. Good night. Have a good one.